1993 was a shock because of one game, Doom, basically reinventing the FPS genre. But many players were still left with Amigas underpowered to run such an engine. Many games tried, but in the process had to use tricks, remove features, or reduce screen size. They were fun, but couldn't come close to the original. I am KK of Altera Group, and here's my try to change that. Up until now, running the game took us directly straight to it. That's it. No splash screen, no game name, no options menu, just the game. Even the game name itself was nowhere to be found. When I said that, John immediately started flipping through the ideas. At first, he started basic but promising. Then he added a scary school as the game's splash screen and experimented with the logo typography. I wasn't a big fan of scary schools and we needed an in-game menu as well, so he started to work on basic menu textures. Tiling would allow us to save some memory, so it was a good start. So John experimented with some tiling patterns, which I briefly show you here. I kind of like this one, being both interesting and simple at the same time. In the end, we settled on this simple menu with the game title, which we hoped could fit in one executable with the game, given the size restrictions. One thing I noticed was that we could produce the background here by repeating a small texture and applying the blood layer over it. For now, I definitely wanted the game to stay as a single exe file until the demo is out, which meant that everything should fit together in RAM at the same time, including the menu. On the plus side, having a compact menu would mean that we can switch to menu and back in the middle of the game without additional loading, so we decided to give it a go. While keeping the entire 5 bits per pixel image would take over 46 kilobytes, we could store one 4-bit 48 by 48 pixels texture and one 1-bit full-screen blood map, taking only about 10 kilobytes. Then the texture would be used to fill the screen with 4 bits per pixel image, and the blood bitmap would be used as 5th bit of the color index to change some colors to bloody versions. So John prepared the layers accordingly and sent me detailed palette and color mapping instructions. But first we need to be able to start and stop the game engine at will, which isn't trivial considering all the interrupts and copper running. I've got it kind of implemented. Press escape to stop the rendering and see the blood mask for a while. Kind of. Apparently sprites were only partially disabled now. There is also one more thing missing, I didn't spot until later. Comment if you have seen it the first time. Handling the keyboard in our new menu was next. I already had keyboard handled, but something did not quite work here. The keys are handled in the interrupt and looks like the C compiler played a trick here, which I only came to realize one evening later. Clearing the pressed key code to 0 got propagated, which made the menu loop wait not for the escape key, but wait forever. This is one of the rare times where the volatile C keyword comes in handy, preventing optimization. Fixed. The escape key together with the background texture I added next started to feel like we are really getting somewhere. And looks like our plan to reduce background memory usage really worked. Just a little cleanup next, to prevent background from flashing white during transitions. To decorate the background, let's start with Dread Letter graphics. Since the background is ready, we can simply bleed them with the blitter. I did this already a lot in other Amiga projects, so this should be easy, right? Well, okay, let's try again, step by step. The mask is working. The color is not. I've got the color to work as well. Okay, we are now getting somewhere. Programming Blitter to move it should be easy. Or maybe not. Fixed. As I plan to make the game intro with the letters moving, let's check the drawing performance. A better way of checking drawing speed is to change the background color, for example to green, for the duration of the routine. During this time, the screen electron beam, or the one simulated on our LCDs, will paint the green bar proportional to the drawing time. Drawing of all the letters should fit completely within one screen, plus a bit of invisible border space, or the animation will drop to half the frame rate. Luckily, we fit with our rendering in one frame time for now. The animation will also have to clear the letters with the background before drawing them again in a different position, so I took the time to optimize the blitter setup routine to assembler, which of course produced a new wave of funny blitter glitches before getting things right. We didn't win too much performance, so this turned to be clearly a premature optimization, but it still might help. To make the letters move, I have to periodically draw them, display them, and then hide them by painting over with the background to prepare for the next frame. And double buffering doesn't make things easier, so it was obviously broken the first time. To see clearly where the background is being repainted, I started with a black background, which helped to pinpoint the issue. Now we can see the refresh happening exactly where it needs to, rounded to the nearest 16 pixel boundary for blitter performance. Putting it all together, we can move all the letters smoothly and independently to make a nice intro animation, and it looks like we still fit in one frame time. But at this point I left the letters for a while and focused on the menu itself. To save memory, as usual, we keep the menu font as a 1 bit per pixel mask. It's compact, but needs some tricks to look nice in the menu. Luckily, the menu text is mostly static, so we can overlay this mask as many times as we like to improve our font a bit. So first, we draw the text shadow, offset by 2 pixels down and right from the target position. Then, we draw the low-light copy, shifted 1 pixel down. This layer will stick out below the font face and look like the bottom edge. Next, we apply the same trick and draw highlights layer 1 pixel higher. It will protrude above the font and make the upper edge. Then, we draw the font face, covering our tricks and producing the 3D shape. Finally, we use the capper to change face color to gradient for the final result. To reduce amount of drawing, I am first drawing all the letters to an off-screen buffer and then draw it in one go 4 times. Having done this, we can now draw our menu. As we already have the blitter animation under control, adding cursors is easy now. I can also finally print some cheap memory statistics I could only guess before. Now was the time I noticed the menu switch problem I mentioned before. A little all weapons cheat, and let me take some shots. Do you see something off when I return back to the game? And now? When I'm updating the status bar, I just draw the digits that changed. And going to the menu resets the status bar, but not the refresh tracking system. So you can clearly see how even the single digits only update. Added one line of code and let's test this once again. Fixed. Time to add some more color to the letters using the copper. Just one line for now. Because the selection moves, the copper list has to be generated dynamically. Luckily, it doesn't take too much CPU time, and we don't have anything other going on the screen other than the cursors. And here is the final result. Time to implement switching to submenus. Oops. Again. Half oops. Remember, we have double buffering on, so all static graphics must be updated in both buffers. Fixed. Since we have the options working, we can have some fun implementing them. I've gone back to the map to add some extra enemies depending on the skill setting. Keeping the spirit, I decided to do it the Doom way. The skill names are temporary for now, of course. On the very easy mode, you get only the minimal number of enemies. Additionally, you take only half the damage you normally would. Got down to 81% health after 2 shots. On the easy mode, you still get minimal number of enemies, but no special treatment. So it's 60% health after 2 similar shots. On the normal mode, you get average number of enemies and things start being fun. And the hard mode introduces even more enemies. Keep in mind that we can choose separately for each of the 3 core skills which enemies, weapons and objects appear and which don't, so this doesn't have to be as boring and simple as 1, 2, 3 in the test here. And finally, the expert mode. Maximum enemies that are also way better shooters. I also made the enemies move twice as fast on this skill now. And they just don't want to stay dead for too long. Good luck with this, you'll need it. I should probably rename this one correctly already. Let me know if this happens to still be not enough for you. The working options also call for the options menu, especially since there is one thing I wanted to test and show for some time already: the video modes. For completeness, here is the current default mode. 3.68 vsyncs per frame at the starting location. The scanlines mode simply skips every second scanline instead of doubling them. At 3.50 it's a teeny bit faster because DMA is stopped every second line, giving more bus time for CPU and the blitter. The next mode, Shake, was a simple try to improve the dithering a bit by moving every second scanline 1 pixel right. Vertical stripes are gone, but all edges are also blurred. At 3.70 the performance is similar to the default mode. And the final, Checker mode. This mode stops doubling the lines and uses an extra blitter pass to produce a perfect checkerboard dithering pattern. Naturally, at 4.04 it costs us almost half a frame in performance and some extra chip RAM to keep the full screen now. But the dithering is perfect now. So, here are the 4 options with their performance. Let me know in the comments which one do you like best and why. Okay, let's see how these modes work for the gameplay. Default mode first. We start the map, look around a bit, fight the 2 baddies, and look at the detailed computer texture. Okay, maybe not this one has still bad alignment. Now the scanlines mode. First impression, it's so much darker, but the scanlines help hide the low resolution. The bad guys are almost invisible though. Yet, this mode is still so simple and gives a tiny boost, so I'll definitely keep this option in. The Shake mode. First impression, blurry. And it makes the bad guys look like even greater mess of pixels than normally. Looking straight at the wall, it's not bad, but I doubt its usefulness otherwise. And the checker mode. First impression, clean and blocky. Somehow improving the dithering made low resolution even more obvious. Definitely more obvious, looking at the enemies. It's an interesting mode, but given that we pay with RAM and performance, I don't think I'll keep it. Especially that we already have some ideas how to improve sprites and texture resolution, and this mode would destroy the effect. But more details about this will come in due time. Again, I encourage you to share your thoughts in the comments. Another option I made by now is the mouse sensitivity, which ranges from 0 to 15 in a kind of exponential curve. But this is hard to show in the video, so I hope you will find your spot yourself. Further options will come in due time, but that's enough for now. Back to the coding of the game intro. This is the mockup I have animated for the last video, and now it's time to implement it on Amiga. To let the letters fall from the above, we have to clip the letter graphics against the upper edge of the screen, and this is the typical result of human error on Amiga. Even the guru is not meditating, because I have kicked the system out to save RAM. So I had to meditate on it myself and steadily fix the issues. Until I finally had it working. John made the screen 3 pixels too high, just to allow adding a slight screen shake here, which also broke the copper gradients a bit. But finally, it worked. For John, it was a bit too slow, so I made this quicker version. Finally, we added slight fade-in and settled for something in between. The menu system will also be abused to produce the level end screen. For this to work, I had to go back to the map editor and mark properly our secret sector. The level exit is going to be marked as well, giving the level a proper end. For testing, I set up the menu system to show the end screen whenever I open the menu. It contains all the usual stats you would expect here. After starting the map, all features are counted properly. Waiting a bit to test the timer. The counter is counting elapsed video frames, so should work nicely for speedruns. Let's test our secret sector now. And apparently it works. The special item count also works nicely. So let's get some monsters next. 1. And 2. The shotgun also counts as an item, so let's fetch that as well. And finally, let's test the level exit. Nice! Finally, it starts to feel like a real game. The part time is of course temporary and way too low. Since we have a timer and the exit, let me present the first Dread speedrun ever, on hard difficulty naturally, with 100% monsters, items and secrets. Let's ignore these guys for now. And the way I implemented the movement, strafe running, is working perfectly. The red doors still don't check if you really have the card, but let's pretend they are and fetch the red card now. The shotgun was the reason I dismissed this guy earlier. but now it's their time. I definitely should have one-shot them all, but I didn't really train for this run. And the final stretch. Done in under 50 seconds. A botched run by all standards, but still fun. This time will definitely go up when the map is fleshed out with monsters and stuff, and will hopefully go down again when the executable is released for you all. Some time ago I noticed a glitch in the physics which leads us to any percent speedrun category. And off we go into the void. We can see a classic Hall of Mirrors effect as I'm circling the map around. The engine doesn't expect us here, so it occasionally renders a room or two. Done. In about 20 seconds. But I'll definitely have to work some more on the physics. And last, and probably least, the credits page. In the meantime, John sent me updated font graphics, so I switched to them as well. And that's all for today's episode. I hope you had fun watching this and didn't get discouraged by maybe lengthy programming fails write-up I served you this time. In any case, if you have any suggestions how would you like next episodes to look like, please write them in the comments. I do read them all. And if you want to receive notifications about the next videos, please subscribe and click the notification bell to make sure you get one. See you next time and stay safe.